In this video, I'm going to go through and show you how to work through, utilize ZooTools, the add-on to Google Sheets, and to answer the questions as part of the ZooTools Part 1 activity. So what I have here, and you should go ahead and click the link in Canvas to access this and make your own copy in your own Google Drive so that you can go through and follow along with me, is the data sheet, the responses from the survey that everyone filled out. So in part 1, you went through and looked up what your latitude of your hometown was, the longitude of your hometown, the latitude of Mount Sac, the longitude of Mount Sac. You entered these numbers into a website to calculate the distance between them, and then you answered 2 simple questions, just so we can get an idea of more about each other. So, in order to go through and work on this particular activity, we're going to learn a little bit more about each other through some of the silly questions and where you come from by looking at the data, but also get a better understanding about what we mean when we use the term data. So we're looking at this data table. We've talked about each of the columns, and each of these pieces of information is considered to be data. And data, by the way, is one of these weird words that can be both singular and plural nowadays. So in case it sounds funny, it's Latin, so you know why. So we can have data of different types, and we're going to go through and investigate that. We can take some data and turn it into new data. So we used our latitude and longitudes of our hometowns and Mount Sac to figure out distance. So we used this data to calculate that data. So we can generate new data from existing data. Some of the questions that you're going to need to answer as you work through here is, the first one is, why and how is it important that we organize data? So I had you all fill out a Google form. It put this into this nice spreadsheet for us. So think about the role of organization when it comes to data. And you'll also want to go through and think about what other forms of data exist, maybe that you even generate daily on your phone or on your computers. So you entered this into the form. So you created this data and provided it to me, and I am providing it to your class. But what sort of stuff is collected automatically, for example, on your phone? What are the other sources of data that are created just as we go through our daily lives? So let's go through and take a look at how we can visualize this data. And we're going to do that in a few different ways. So we're going to utilize the ZooTools add-on. So you were asked to go through and install that into your Google Sheets on your computer back at the beginning of class. So if you haven't done that, you want to make sure you do that now. You access it by going to add-on and then ZooTools for Google Sheets. And we're going to start with the map helper. So if I click the map helper, it pulls up a window. And it knows the titles of each of our columns in our data sheet. So I'm going to do latitude and longitude for our hometown. So if I go through and select those as my 2 columns and then I click map, what it's going to do is it's going to pull that data and map it. So it knows that everything in the latitude column is a latitude and everything in the longitude column is a longitude, and it's going to map that for me. So we can see that the majority of students live not only in the US, but also in California. But we also have this other group of students over here in China. So let's zoom in and take a look at how many there are, see where they are. China's a big place, it's got lots of people. But we have 2 entries relatively near to each other in the middle of China. Not necessarily even by any big cities. So these are roads going through here, so not even near any big cities. So you're going to want to think about why that is. What's going on here? We can go through and take a look. I'm zooming back out very slowly at the entries that are in California. So we can see that the large majority of people's hometown is Southern California. And then we've got at least 1 entry up here in Northern California. So some of the questions that you're going to need to answer along the way are things like, what city is the furthest hometown for one of our students, whether that's in the US or otherwise. So if we're looking at this data, and again, right now we've got just the US and the few entries for China further away. So here's the data for Mount SAC. You can see that most of them are in one spot in California, but we have a few extraneous entries for other locations. 2 are in the middle of oceans. Another one is over in China. If you hover over them, you can take a look at what the values are for those individual ones. So you'll want to go through and figure out what went wrong. Are some of them just random numbers that got put in there? Is there something more obvious? Maybe just a mistake that was made in the entering that makes some of these other entries different than what we see when we look at Mount SAC. Even zooming in to the Mount SAC area, we can see that there are some errors or differences here. So you'll want to go through and think about what caused these errors. See if you can pinpoint the actual piece that is incorrect in doing these. And then we can go and take a look at the hometown data again. Close that out and start over. If you happen to try and just map on it again, it just adds the data points. So we want to start with a fresh map so we know we're seeing the information that we want to. So does your results and what you're able to find out from the Mount SAC either map and or looking at the raw data itself help you understand why we see some of the data points that we do here in this map of people's hometowns? Is it more likely that there are actually students whose hometown is from China? Again, you've got to know each other in the videos. It's certainly possible, but is it more likely that that is what happened, or is there another explanation? So you'll have a question in your assignment write-up about this as well. So we're talking about longitude and latitude. Maps are an obvious way to visualize this data, but there are other ways that we can visualize this data as well. So I'm going to close our map and we're going to go through and take a look at a scatter plot. So for a scatter plot, we can use ZooTools again. So we're going to use this one. And there's a few other options in here that you will learn more about as we work through more into the course. You can play with them yourselves, of course, if you're interested. But right now we'll do scatter plot, and it's going to pull up a window on the side here. So we want to select the X variable. That's the one that goes on the horizontal axis. So if I'm thinking about longitude and latitude, the more appropriate thing to put on the horizontal axis would be the longitude. So those are circles that go up and down. So something that has the same longitude but a different latitude would be further north or south from each other. And then something that has a different latitude would be the same east of west, but different, different in the north-south direction. So same latitude would be on the same east-west line. So if we plot this, it's going to draw a little tiny plot down here. I can click Send to Sheet, and it'll actually send it to my sheet, and it's going to make a new tab here called Charts. Okay, so we've sent it to the sheet. It looks a little bit different than it did on the side view, and that's because it's forcing it to start from 0 on the vertical axis here, which again is the longitudinal axis. So we can do some editing in here. We need to be careful. You might break things. You can always try and hit the go back button, or you can always have to just make a new chart if you need to. So I'm going to do some customization. I'm going to make sure that my vertical axis has a title as well. So that should be latitude of your hometown. So now we can see we've got axes titles on both. That's always important so you know what's going on. We can go through and make changes to the axes as well. I'm going to start with the vertical axis here. So the vertical axis, again, it forced the minimum to be 0, but most of my data points are here and here, so it's a little bit difficult to see. So I'm going to change and make this minimum value 30, and it looks like there's nothing larger than 40, so I'm going to make that change as well. And so looks like we could even go smaller than that if we wanted to try and spread things out a little bit more. So you can see every time I do this change, it's automatically updating my window here. And then I could do the same for the horizontal axis if I wanted to. So it's already at negative something right here. So let's make it maybe negative 120 to positive 120 and see if we lose any of those. Nope, it looks like they're all in there. Oftentimes you can go through and change how often you see the tick marks in here. It looks like it's doing default for everything. Sometimes you can change these values enough to make it easier to see. But at least now we know for sure what these ranges are. So when we're looking at the scatter plot, we can see we've got a bunch of data points here, and we've got a handful of data points over here as well. So in this view, we're able to go through and see things slightly differently, but there's still some similarities. So you'll want to describe in your assignment what some of these similarities and differences are, and especially pay attention to what information is lost by looking at it here. So before we had things on a map. I've got things roughly lined up so that the longitude is in the right direction and latitude is in the correct direction, as we had in the map, but there's still some pieces that are less obvious now that we're looking at in the scatter plots. So you want to think about what information is lost in order to answer that assignment question. And in general, this is something that we need to think about anytime we go through and visualize data. So there can be many different ways to represent a single set of information visually, but sometimes some data are better suited for specific visualizations than others. So latitude and longitude, you get maybe better represented on a map than, say, in the scatter plot, even though there are some strong similarities in here. Bar charts might be better used for various types of category data, for example, and we'll take a look at some of that in a little bit as well. So let's use this, let's go back to our raw data sheet, and we're going to start to look at one of our other columns. So we use latitude and longitude to determine distance. So now let's go through and look at a way that we can visualize the distance. We could do a scatter plot of this as well, although again, you generally need two variables for a scatter plot. So if you're only looking at one variable, a histogram is a good way to go through and visualize that. And what that essentially does is it's a bar chart that counts up how many instances of that particular number. So let's say how many values between 8 and 9, and it shows that as one bar. So however tall the bar is, that's how many values you had within that particular range. So in order to make our histogram chart, I'm going to do this for distance. So I want to select the distance column. The histogram is not in the add-on, it's actually built into Google itself, so we're going to select chart. And what that does initially is it does two things when you first select chart. One, it just plops it right in the middle of your spreadsheet, whether you want it there or not. So I'm going to slide this over so it's out of the way and we can work with it a little bit better. And number two, it makes what's called a line chart, which is actually not what we want to do. So I'm going to go over to chart type, hit the drop down menu and scroll all the way to the bottom and select the histogram chart. So now that I've got the histogram chart, what it's showing me, and it's got some odd values, and we'll go through and take a look at how to improve those in just a minute. But essentially it's saying that we've got between distances of negative, and how you have a negative distance is a question you can ask yourself, negative 1,666 kilometers to 6,666 kilometers. We had more than 35 people select that distance. Great. Again, we talked about crowdsourcing data. There may be some data in here that maybe we don't believe is correct. You can go through and take a look at that in your own personal one. You can try and block that stuff out. I would, for example, ignore the negative distance one. I think something went wrong there. And we can scroll down and look to see maybe some of these distances are very large because there might have been some sort of error. So I'm actually going to focus on distances from 0 to something less than 6,000, since the US is not bigger. Well, I know it in miles. Well, either way, we saw from our map that the majority of people are in the state of California, and California is not 6,000 kilometers. So I'm going to go over to customization. And again, I'm going to look at the horizontal axis here. So the horizontal axis should give me some options. Oh no, actually I want histogram. Should give me some options to go through and change my bucket size, for example. So that's how big each of these are. So this bucket right now is almost 7,000 kilometers, which is far too large. So let's try 25, for example. Now I've really blown things up because I have lots and lots of buckets, but it's trying to do a very large scale. So now I'm going to go to my horizontal axis, and I'm going to set the minimum value to be 0. That'll get rid of my -1. And I'm going to take a look at this and set the maximum value to maybe 1,000. Or slightly larger than 1,000. I would believe 1,000. Well, it looks like it's actually slightly less than 1,000, so we can go to 1,000 itself. So now if I take a look at my histogram, and yes, the buckets are still, it's a little hard to read some of these, and we can change them in just a moment. But if I take a look at my histogram now, with a bucket of 25 kilometers, I can see that the large majority of students who filled out this survey live or have a hometown within 25 kilometers of Mount SAC, since that's what we are going through and calculating. It looks like there's maybe only 3 people whose hometowns are further away than even 50 kilometers from Mount SAC. So now that we can go through and take a look at a different way of visualizing data, the histogram, we can start talking about distributions. So a distribution is how data, or whatever value you're talking about, is distributed, is spread out. So you're going to need to answer a couple of questions about this graph that we've just made, and you want to make sure you make it yourself, not just use the video to answer, because you're going to need to do this later on in the class. So make sure you understand how to create the histogram graph. You're going to need to answer some questions. Some just, what can you tell from looking at this graph now that we've gone through and created it? What can you learn from this graph that you couldn't learn from the map? What could you learn from the map but not from this graph? How are they related? How are they different? What information is lost when we present it in this histogram of distance as opposed to the graph or a scatter plot, for example? We could have easily done something like that as well. What's easier to grasp? What concepts are easier to understand by visualizing this data in this format as opposed to a different format? So various questions about how we go through and visualize this data. Before we move on to the next bit, I want to talk about some statistics. And some of you may have taken a statistics class before. Most of you probably have not. I never did when I was in college, even though I use statistics fairly regularly now. We're only going to look at very basic statistics, and I'm going to show you how to go through and do that yourself. So you want to scroll down to the end of your data, and I've deleted a lot of the rows, so I'm going to add some extra rows here. And so we're going to go through, I'm going to put some titles over here on the side because I always like to know what it was that I created. And we're going to go through and look for these various columns: the minimum value, the maximum value, the average value, and what's called the standard deviation. And we'll talk about what each of these things are. So I'm going to go through and do it for the latitude, and then you'll be able to go through and do it for each of the other columns to be able to answer some questions. So whenever you're doing a formula, you want to hit the equal sign first, and we're doing minimum, so it's going to be min, and you'll see that it starts popping up. You can either select it And you can even see it says minimum value in a numeric data set, or you can type it yourself, that's fine. Then you need a parentheses, and you can either go through and click in and select it, the values that you want. So I want 2 going all the way down to my last one, which is here, and then end parentheses and enter. And so now it's giving me the minimum value that we were given. Or, we'll show you a different way for max. For max, you can also just type in, I know I'm dealing with column A. The very first row is my titles, so that's not any data that I want. So I'm starting with number 2, and I use the colon, and then I'm going to go all the way down to A39, end parentheses, and enter. And so now this value is the maximum value of all of the latitudes that were put in. I can go through and calculate the average value. I often find it easier just to type it, but you may prefer selecting, that's fine too. Even when I type, you can see that it highlights it so I can visually see what it is that I am selecting. So the average value, and then lastly, the standard deviation. So this is STDEV. It popped up pretty quickly, that one right there. And again, I want the full range of what it is that we are looking at. Oops, and I did something incorrectly. Too many parentheses. There we go. So, maximum and minimum values, hopefully those don't require too much explanation, as well as the average. So if I were to add up all of these values in this column and divide by the number that I have, that's the average. So it's done that for me, so you don't have to do it by hand. Standard deviation is something that describes the spread of values. So we've got a maximum, we've got a minimum, the average will fall in between them. Sometimes you can visually see that the minimum and maximum are spread out a lot. So for example, and once you do this once, you can select them and then drag this little box over and it'll repeat it for the next column. And so if you click into one of these, you can see that it's still doing min, it's doing the same function that I told it to, but now it's switched it to the B column for me. So now this is the minimum longitude that someone entered and the maximum longitude. So if we take a look at longitude, for example, and then as well as the average longitude. Yes. So if I take a look at longitude, for example, I have a really wide range here. But just because I have a very wide range doesn't mean that those values are spread out relatively evenly. If you go through and look at those values, most of those values are very, very close to each other. And so the standard deviation starts to give us an idea of how close are these values to each other. So it's essentially saying that some large percentage is going to be within that value of the average. One standard deviation is typically around 60-something%. So 60-something% of all of the values in this column are between essentially what is 33.5 and 36.7. So looking at the average plus or minus the standard deviation. So the smaller that standard deviation is, the closer it is that the values are to that average that is shown. And the larger that standard deviation is, the more spread out they are away from that average. So we'll be utilizing this idea of standard deviation to go through and learn about other objects and other data as we move along. So you will go through and do this for distance to answer some questions. And that way we can go through and think about distributions, what they look like. So this distance distribution, for example, is very much skewed to small numbers. So that means the standard deviation, I would guess, and you'll go through and verify, is going to be fairly close to this. Although we are not displaying all the values that we got, and so that will make a difference. So you can even experiment with going through and maybe taking some of those out and seeing how it changes as you move along. So there are other types of graphs that we can go through and make and can display information. So we've got commute, for example, is one of them. So let's go through and make a chart for this one. And it's trying to do a histogram, which is not what I want. So let's move this over so we can see things. You can also shift them over to the charts one if you prefer. We could do bar graphs, for example. So car, walk, bus, and evidently no one selected train, so that one's 0. So we can see that most people get to Mount Sac or before Mount Sac shut down via car. There's a handful of people that are close enough to walk and a handful of people that take the bus. We can go through and take a look at pie charts, for example. Let's do one for pickles, and we'll take a look at the results for that. And again, I'm going to move this over. You can also move it to its, we'll just move this one to its own sheet so that we can go through and take a look at it. So now it's much larger and easier for us to go through and see. You can always edit these tabs down here and rename, so we can make this the pickles, if I spell it right, the pickle sheet. And I can edit the chart, right? I don't necessarily have to use this type of chart. In fact, I want to look at a pie chart, and it nicely suggests some. So once you use some more often, like for example the histogram, it might pop up more often. So let's look at a pie chart. 60% of you unfortunately like pickles. You would get along great with my husband. I hate them, even when I'm pregnant. There is no world where I will ever enjoy a pickle. And so roughly 40% of you agree with me. So right on. I'm with you. So again, lots of different ways to visualize data, even though I'm getting a little silly here. And that you'll want to go through and utilize both this video and make sure that you're familiar with making some of these charts if you're not already. In particular, the histogram and the scatter plot you may be less familiar with. So the very last thing that you're going to need to do in this activity is to make some final calculations so we can compare the distances that we found in our spreadsheet here. So the final questions are going to ask you to make a few calculations. I've given you the formula, comparing the maximum distance shown here to the circumference of the Earth. So first you'll want to go through and Google the circumference of the Earth. We want to make sure that it's in the same units as our data, and I explicitly asked for the data to be put in with kilometers. So you'll want to make sure you Google it with kilometers. Of course, now you can see it in the video, but you'll have to Google other things as well. And so we're going to go through and take our maximum distance and divide it by the circumference of the Earth. So if you don't have a good calculator to use, then you can use Wolfram Alpha for this or other activities. And I want to highlight a few things because I often see some errors when students go through and do things. So whenever I'm doing division, try and utilize parentheses as much as possible. So let's say that the maximum distance any student was from Mount Sac was 376 kilometers. Now, 376, that's not a big deal. I'm going to put that in parentheses just to make a point here. And then I need to divide that by the circumference of Earth in kilometers, which was 40,075 kilometers. So I could just write that number in here. I've done that division. Now if I multiply by 100, then the number I get out is going to be the percentage. So it's essentially the percentage away, the furthest distance away is from compared to the circumference of the entire Earth. So it's just under 1%, for example, for the random distance that I just selected. But the main thing that I want to point out is we've learned about scientific notation. So if you're going to end up putting in a number that utilizes scientific notation, like perhaps the very last question, then this is where the parentheses become very, very important. So if I turn this into scientific notation, again, I want to make sure I get the same value. So I'm moving that over 1, 2, 3, 4 decimal places. I need the caret for the parentheses. So if I hit enter, I should end up getting this exact same result that I got before, that just under 1%. But if I hadn't put these parentheses in, I would get a very different number. And this is why I utilize the parentheses on so many different things. Okay, it's trying to be smart enough to interpret this, but it may not always. So especially in your calculators, if you were just to put things in exactly like this, then you could get very, very different numbers because it could be going through and doing the results in a different order than what you expect. So Luckily, Wolfram Alpha was smart enough to try and figure out what it was that I was doing. It may be because I took the parentheses away, but in general, your calculator may be doing something more like this, where it's doing this division first and then it's going through and multiplying, which of course gives us a wildly different answer than what we would expect. So make sure you utilize parentheses in the correct places when you're doing your calculations so that you can tell that your answers are correct. You can also, I love that Wolfram Alpha gives you the interpretation of what it's doing, so it's telling you exactly how it's doing it, even when I didn't put those parentheses in, which is fantastic. So this should give you all the information you need to finish up the ZooTools Part 2 activity, and then you'll just submit that on Canvas as usual.